Hello and welcome to Renew, the show about the College of Forest Resources at Mississippi State University. The College of Forest Resources promotes and enables the conservation, management, and wise use of our natural resources. I'm your host, Leslie Berger. Today's show will feature the Department of Sustainable Bioproducts, one of the 3 units within the College of Forest Resources. Here to represent that department are 2 of the faculty members and a postdoctoral student from that department. Dr. I'm going to get it wrong, I'm sorry, Dr. Zhufang Sang and Dr. Jaeling Kim. No, correct me, I'm so sorry.
That's okay. My name is Yoon-sang Kim.
Yoon-sang Kim.
I'm assistant professor in SBP.
Okay, so where are you from originally? It's causing this poor American to stumble over your language.
That's totally fine. I'm originally from South Korea. I entered the PhD program at Georgia Tech 2009. It's actually a materials program. At there, I did work on nanocomposite material, actually 100% synthetic polymeric material. And I did 2.5 years of postdoctoral research at University of Georgia in Athens. And that's where I switched my gear into biomaterials. I did some nanocellulosic materials research there. And in 2017, I got to join this Mississippi State University in the Department of Sustainable Bioproducts.
Well, we're glad you came to us from Georgia.
Appreciate
you
it.
saw the error of your ways, is that right?
Yeah, most of,
Wrong Bulldogs, wrong Bulldogs.
Wrong Bulldogs, yes, that's right.
But so you 2 are working together. So you're a postdoctoral person in the lab?
My background is a little bit different with Dr. Kim because he's from material science, and actually I'm from the wood science. So I got my undergraduate and master's degree in China, which is Nanjing Forestry University, in the major of material science, but specifically focused on the wood science. Okay. So, and in 2013, I joined MSU and I become a PhD student. I'm started to working on lignin, which is one of the 3 major components of wood. I'm utilizing lignin to making some products, which is value added, which is bio-based materials. And I used to use lignin to make some carbon materials. And in the December 2016, I graduated, and then I become a postdoc. Okay. I switched my direction, but still use the lignin to making some bioproducts. And this is our today's topic. I'm making some polymeric materials by lignin to replace some petroleum-based resources for the plastics.
Sure. Yeah. Okay. So in the Department of Sustainable Bioproducts, what you're looking for is the opportunity to take biological things, the word bio, and create products that we can use to help better our society or use in everyday products.
Right.
So you have some things that you brought with you to demonstrate just some of what that is. So could you explain what you got? I recognize we have some kind of insulating material sandwiched between some plywood. It looks a little bit like an ice cream sandwich. So explain how is this related to a forest product and what we use it for.
So this project was primarily done by Chef Feng Zhang, but if you don't mind, I can explain a little bit. Okay, this is some lignin powder from wood, sort of raw material, and then we convert this into this thick liquid. Okay. We call it biopolyol. And from there, we can make this polyurethane foam, which is actually thermally insulating. So it would be useful for actually construction and many areas of building applications. And from there, we could fabricate this tiny laboratory scale structural insulated panel, SIPs. And then this is sort of the biggest scale we could make in our lab to show, okay, this is something we can bring up in terms of scale, and then we are hoping to work with some industry who are interested in utilizing biomass. Actually, we are substituting some synthetic polyol, making this polyurethane foam. So we are actually up to 50% of substitution with this biomaterial to make this structural insulated panel.
Right. So instead of some kind of oil-based, petroleum-based, or some kind of other synthetic non-renewable product, you can create this from this, which originally comes from trees, which is renewable.
That's right. Actually, a lignin, that's the major.
Which is part of the tree product.
That's right.
Okay. You all brought some pictures and videos with you that I would like for us to take an opportunity to look through.
Sure.
So
Oh,
if
yeah.
you would explain what we've got, this relates to what you just said.
Yeah. So the thing is, lignin is renewable, and we try to making some renewable products from the wood products, which is lignin, and which can be make the plastic more environmental friendly. But the thing is, lignin is a solid part, as you can see from this image, and which is hard to be utilized, and because which is very have very less reactivity. So what I did was I tried to do some modification process and to make lignin is more reactive. So here's the process I did. I just make some process, but you can see from this image that so after modification, and I can increase its reactivity, so which gives lignin the power to make these such a good products, which is have the comparable properties with the commercial ones.
Right.
And this the first slide that I want to show you. And then the second slide I'm showing here is actually the sample I bring here, which is by this method I can scale up at least to making these 1 feet by 1 feet large sample. And our ultimate goal is to make the true products, which is 4 by 8 feet, which can directly use as our wall for the buildings.
Sure.
Okay. And I also
No, go ahead.
bring some videos to let you know give you some idea of how this work was done. So if you look at the first video, like this is actually the modified lignin already, and I mixed lignin with another part of the chemical, and putting some bloom agent.
It's like a baking.
It's right. It does look
That's
like
how
it's a
the
little bread
form was
rising.
made.
Sure.
Yeah. So, and in order to make these sandwich materials, so we have to have some facet materials, as you can see, right? So we just putting the chemical in between these faces, and we can make these sandwich panels, which can be directly used as a wall.
Oh, that makes sense, because you have to blow this up into a shape.
Yes, yes.
And then otherwise, like if you try to do a bread or something like that, it doesn't have any structure. It turns into like a pancake instead of a loaf, and so you have to control that. But I could see when you try to scale it up to even larger, then it becomes more challenging to get it to retain its shape. It would want to break, just like a bread that over rises and then falls. That wouldn't be very good if you're trying to make something that's going to be strong but also insulative. You need it to have some rigidity, but also that flexibility.
But as you can see from the video, the beauty of this work is we don't need to have the adhesives to bond them together. We can just directly put in the chemicals into these lignin-based chemicals into the panels, and then let the chemicals rise in, and then the wall is made.
Right, so it saves a step in the manufacturing process. You don't have to glue it all together.
That's right.
You can let the foam be the adhesive that puts the two sides together. So that's really very interesting. That's very interesting.
Yeah, so far we have focused on actually materials level research. We actually looked at how to make this conversion process into foam more efficient and more, I think, less energy intensive. And now we are actually switching our gear into sort of demonstration level, how to make this panel big. And as you mentioned, if you want to try make a big panel, and there's always issues with how homogeneous or the thickness would vary. So we are actually in the stage of looking at scale things up, and that actually aligns really well with the interest from industry and other stakeholders, because if we don't make real products, and then what's that going to be useful?
That's exactly right. Right, and so that's what I was going to ask you. Where do you see this industry going next? To be able to take this to larger scales, or whole new product lines, or 100% lignin based, or where is the next steps?
Actually, both. In terms of existing products, industries are interested in more bio-based products that could replace some of the 100% synthetic with comparable performance to the commercial ones. So that's one direction we are actually hoping to go through. And another one, I think, is we actually want to incorporate another functionality into this panel. I think this is structural panel for buildings. So what if we make this less fire hazardous,
Yes.
putting some fire retardant material? Or what if we could make this more energy saving? We could embed some energy saving materials, for example, phase change material that could absorb and release heat depending on the external stimuli. So that's some of the direction we are hoping to achieve.
Right.
Right.
So where do you see yourself in, say, 5 years? You're doing a postdoctoral position now. That's not a long-term thing. That's a stage to something else. So in the ideal world, where would you go? What would you do?
Yeah, so when I look at myself, I working on the wood, the bio-based material for many years. I mean, more than 10 years since I enrolled as a college student. So I like this major because the green and sustainability will be our future, right? Because the depletion of the petroleum-based resources and also the increasing of the environmental concern, right? So in the future, I will look at myself as a wood scientist first, and I will utilize my knowledge to making many different kind of sustainable biomaterials and biocomposites, and I will looking for some research position, and it's better. I mean, in university, and I enjoy the research, and so I will contribute myself and for the development of these sustainable materials and bioproducts, and which can be benefit to our society and the environment.
Right. Well, that sounds like a perfect mission, and the work that you're doing is so exciting to me. I am not from that field, but I appreciate the work you're doing and the value that it has for our society as populations increase, as our renewable resources become more and more critical to be able to manage. And so I think the work that you're doing is really exciting, and I appreciate you coming by this afternoon and sharing with us a little bit about what you do in the Department of Sustainable Bioproducts. I thank the rest of you for joining us here today. I hope you've learned a little bit more about some of the exciting work that's going on in the Department of Sustainable Bioproducts at Mississippi State University in the College of Forest Resources. College of Forest Resources looks for ways to do a better job of managing our resources and providing opportunities not only for students here at Mississippi, but also from around the world, as you saw today. So I appreciate the time that you've given us, and I look forward to you joining us again in the future. And until then, I encourage you to get outside and enjoy the natural resources that surround us. I've been your host, Leslie Berger.